So welcome to our discussion for stress. So for this video, we're going to solve the problems in your module with respect to shear stress, bearing stress, and working stress. So we have here problem number 1. By the way, I will no longer be discussing about the principles because I have already discussed that previously. Okay. So for problem number 1, we have here bar A, B, C, D, and it is consisting of 3 cylindrical steel segments. Okay, so tatlo yan with different lengths, cross-sectional areas. Actual loads are applied as shown. So we need to calculate the normal stress in each segment. So what is the normal stress here, the normal stress here, and the normal stress here? Okay, so from our discussion, we were able to discuss that if the force or the actual force is going away from the material, therefore it is tension. Okay, so though gagamitin pa natin siya medyo maya-maya. Okay, so let's try to solve. Okay, so if I am to determine the force PAB, I am going to cut my section at this portion. Okay, so with that, I'll be introducing the free body diagram of PAB. So this is 4,000 and this is, let's say, PAB. Okay, so summation of forces horizontal is equivalent to 0. All forces that are pointing to the right should be positive. So I have here negative 4,000 plus PB is equivalent to 0. Transpose this to the other side of the equation to make it positive. Therefore, PB is equivalent to 4,000 pounds. Okay, next would be PBC. Okay, so for PBC, redrawing that, we will be having this free body diagram here. So this is segment BC. So this is AB and this is BC. And I will cut it at this portion. Okay, so we have here 4,000 pounds. Then I have here 9,000 pounds. Okay, so I'll be assuming the direction of PBC towards right. So summation of forces horizontal is equivalent to 0. All forces towards right should be positive. So we have here negative 4,000 plus 9,000 plus PBC is equivalent to 0. So we have here 5,000. Transpose it to the other side equation. That would be PBC is equivalent to negative 5,000 pounds, or that is equivalent to 5,000 pounds pointing to the left. Okay, so the next thing I need to solve would be the PCD. Okay, so you have here PCD. The thing is, if I am going to have it here from this point to this point, medyo mahaba na. So it's better if I'll be starting here, then I will cut my section at this point. Okay, so redrawing the free body diagram, this would be the free body diagram. You have here 7,000 pounds. And let's say that this is PCD. Okay, so summation of forces horizontal is equivalent to 0. All forces to the right should be positive. So I have here negative 7,000 plus PCD is equivalent to 0. Therefore, PCD is equivalent to 7,000. But basing it on the direction of our arrow, it is pointing to the right. We said we are having our reference at point A. So the force here is pointing outwards from the material. Therefore, it is tension. So any direction that is opposite to the left is compression. The PBC here is pointing to the right, therefore it is compression. Then we have here PCD is also pointing to the right, therefore it is compression. So these two are in compression. Okay, but there's another way of solving it, easier and faster. So we have here what we call the axial diagram. Okay, so we have here our axial diagram. We have here 4,000 and it's pointing outwards from our material, therefore it is tension. So we have here from 0, it is positive going up because it is positive 4,000 and it is tension. So we have there 4,000. There is no change in load from point A to point B, so it will be a straight line to the right. Next, we have here 9,000 and the direction of 9,000 is opposite 4,000. Therefore, it is compression. So from there, 4,000 minus 9,000 is negative 5,000. So negative 5,000. And again, from point B to point C, there is no change in loading. Wala tayong nakalagay na load dito. So it will still be a straight line. Straight line from point B to point C. Okay? Then, at point C, we have another compression, 2,000 pounds. So from 5,000, negative 5,000 minus 2,000, this now will be negative 7,000. And there is no, again, change in loading from point C to point D. So, straight line. Then, on point D, there is a tension of 7,000 pounds. So, therefore, it is going back to 0. So, the beginning is 0. Therefore, the ending should be 0. Okay? So, we have here 4,000, 5,000, and negative 7,000. So, PAB, we have PBC, and we have PCD. So, we can now solve for the stress. So, we have the stress, the normal stress, the normal stress AB is equivalent to the force AB divided by the cross-sectional of AB. And that is equivalent to PAB. We have 4,000 divided by the cross-sectional area of 1.2 square inch pound. So solving for that, we have 4,000 divided by 1.2. We have 3,333.33 pound per square inch PSI. Next, we have the stress, normal stress at BC. So that is PBC divided by the cross-sectional area of 1.8 square meters, 1.8 square inch. So that is negative 5,000 pounds divided by 1.8 square inch. So that is equivalent to 5,000 divided by 1.8, 277. £78 per square inch, so that is PSI, and that is negative. Okay, or it is equivalent to 2,000, or it is equivalent to 2,777.78 pounds per square inch, and that is in compression. Next, the normal stress along CD, and that is the PCD divided by the area along CD, cross-sectional area, and that is negative 7,000 divided by the cross-sectional area of 1.6 is equivalent to 4,375. Negative 4,375 psi, or that is 4,375 psi compression. This one is also in tension. Okay, so let's have problem number 2. So for problem number 2, for the truss shown, we need to calculate the normal stress in AC. So the normal stress in AC, and next we have to solve for the normal stress in BD. Okay, so the normal stress in BD. The cross-sectional area for the members is 900 mm squared. So what I need to do first is to solve for the reaction. So this is a roller, therefore it will only have one reaction, and that is vertical. This is a pin, so that would be A vertical, and that would be H vertical, and that would be H horizontal. Okay, so since I'll be focusing on this side of the truss, what I'll do is to have my moment at point H, so I can have my A vertical. Okay, so summation of moment with respect to H is equivalent to 0. All forces rotating clockwise should be positive. So I have here A vertical rotating clockwise, that is positive, times a lever arm of 4, 6, 12, 4, 8, 12, 16. So that is 16. Okay, next I have negative 30 because it is rotating in a counterclockwise, therefore it is negative. So negative 30 times a lever arm of 4, 8, 12. Next I have 70. Okay, so 70 is rotating in a clockwise manner, therefore it is again negative times a lever arm of 4, and that is equivalent to 0. So you have A vertical is equivalent to 40 kilonewtons. So for problem number 1, I only need to solve for that's AB. So I need to solve is AC, not AB. Okay, so erase. So I need to solve for AB. So what I'll do is use the method of section. So I'll cut it here. So if I am to redraw the free body diagram, that would look like this. Okay, so this is 40 kilonewtons. This is 4, 3, therefore that is the square root of 5. So that is AB. This is also AC. Now to solve for the horizontal, I need first to solve AB. Okay, so summation of forces along the vertical axis is equivalent to 0. All forces pointing upward should be positive. So I have here 40 plus AB times the vertical component of the slope, which is 3 divided by the hypotenuse of the slope, and that is equivalent to 0. So we have 40 plus negative 66. So AB is equivalent to negative 66.67 kilonewton. Therefore, it is 66.67 kilonewton, and that is in compression. So our assumed direction, which is to be in tension, is wrong. So it should be in compression. Then we can now solve for AC. So summation of forces horizontal is equivalent to 0. All forces towards right should be positive. So I have here AC minus AB. What is AB? 66.67 times the horizontal slope, which is 4 over the hypotenuse of 5, and that is equivalent to 0. So we have AC is equivalent to 53.336 kilo Newton, and it is in tension. So this is also equivalent to AC is equivalent to PAC. Okay? To solve for the stress, stress along AC is equivalent to the force AC divided by the cross-sectional of member AC. Okay? So that is equivalent to 53.336 times 10 raised to 3. So that would be in Newton divided by the cross-sectional of 900 mm squared. Okay? So we have 53.336 times 10 raised to 3 divided by 900. And that is equivalent to 59.26 megapascals. And that is in tension. Next, we need to solve for member BD. Yes, this is member BD. Now, to solve for member BD, what I am going to do is to cut it here using the method of section. So, I will be having 3 unknowns, and I will redraw the free body diagram. FBD, FBD, so we have if you look closely, we have 3 unknowns. We have BD, we have BE, and we also have CE. Tatlo yung unknowns natin. Now, to eliminate this, the 2 unknowns, what I'm going to do is to extend BE in such a way na magmi-meet din sila ni CE if extended. And that would be point E prime. Okay? So, I only have BD as the left to be unknown. Okay? So, summation of moment with respect to E prime is equivalent to 0. All forces that are going to rotate clockwise will be positive. So, 40 would be rotating clockwise with respect to E prime. So, that is positive with a lever arm of 4 meters, and that would be 8 meters. Then, 30 would be rotating in a counterclockwise manner. So, it is minus 30 times a lever arm of 4. Next, ang matitira na lang si BD. Plus, because BD will be rotating in a clockwise manner with respect to E. Clockwise. Okay? So, we have BD times a lever arm of 3 meters. And that is equivalent to 0. So again, BD is equivalent to negative 66.67 kilo newtons. Therefore, our assumed direction is incorrect. It is compression, not in tension. Okay? So, BD is equivalent to PBD, and that is 66.67 kilonewton compression. Now, to solve for the normal stress BD is equivalent to force BD divided by the area of the cross-sectional member BD. Okay, so substituting, we have negative 66.67 times 10 raised to 3 divided by the area of 900. Therefore, the stress BD is equivalent to negative 74.074 megapascals, or that is 74.074 megapascals compression. Okay. Next, we have here problem number 3. The figure shows a two-member AB AC supporting a weight of W. The cross-sectional areas are 800 mm squared for AB. For AC, it is 400 mm squared. The working stress for AB is 1,110 megapascals, while the working stress at AC is 120 megapascals. So we need to determine what would be the largest value of the weight that can be supported by these members. Okay, so what we need to do is to use the equation of equilibrium. So summation of forces horizontal is equivalent to 0 is all forces towards right should be positive. So I'll be assuming this to be in tension. Okay, so this would be in tension, this would also be in tension. Okay, so for the horizontal, it is cosine. So that would be cosine 40 is equivalent to AB is equivalent to AB and that is minus towards right plus AC cosine 60 degrees. Meron pa ba tayong horizontal? Wala na. Okay? No, hindi dapat siya area. It should be P. P. Okay? So, this would be my equation number 1. So, pero i-simplify natin. So, we transpose this to the other side of the equation to make it positive. So, we have PAB cosine 40 is equivalent to PAC cosine 60. Cross multiply, PAB is equivalent to PAC cosine 60 divided by cosine 40. Therefore, PAB is equivalent to cosine 60 over cosine 40. We have 0.6527 PAC. And this would be my equation number 1. Okay? To solve for equation 2, I'll be using the other equation of equilibrium. So that is, summation of forces vertical is equivalent to 0. All forces that are pointing upward should be positive. So what are those? We have negative W, it is pointing downwards, and I have plus sine 40, we have AB plus sine 60, and that is AC is equivalent to 0, P. Okay? So, since ang sinubstitute ko dito is PAB, isa-substitute ko siya dito. Okay? PAB is in terms of PAC. So, I'll be substituting PAB here. Okay? So, this is my equation number 2. So, sub 1 in 2. Okay? So, that would be negative W plus what is PAB? 0.6527 PAC sine 40 plus PAC sine 60 is equivalent to 0. Okay? So, substituting, we will be having, simplifying rather, 0.6527 sine 40 plus sine 60. So, negative W plus 1.2856 PAC is equivalent to 0. So, PAC, transpose this to the other side of the equation to make it positive, magiging negative W divided by the constant of PAC, 1.2856. Okay, and that is equivalent to 1 divided by 1.2856. 0.7778. 0.7778 W. So, i-substitute natin si PAC para makuha natin si PAB. So, PAB is equivalent to 0.6527 PAC, which is 0.7778 W. So, 0.7778 times 0.6527, and that is equivalent to 0.5077 W. Our working formula for stress is equivalent to P over AC. Okay? So, we have here P in terms of W. So, we are given the stress. So, may stress tayo. Ang unknown natin si P. We have the cross-sectional area. Therefore, P is equivalent to stress times the area in order to get for this, the force. So, we have PAC. PAC is equivalent to PAC stress AC times the area AC. So, PAC is 0.7778. W is equivalent to the stress AC. Stress AC is 110 Newton per mm squared times 800 mm squared. Cancel, cancel. So, W is equivalent to 0.7778 is equivalent to 110 times 800. Ay, mali. This is AC. AC is... No. Mali. So, PAC is equivalent to stress AC times the area AC. So, what is PAC? PAC is equivalent to 0.7778. W is equivalent to the stress on AC, and that is 120 Newton per mm squared times 400 mm squared. Cancel, cancel. W is equivalent to 61.713 kilonewtons. Next, we have PAB is equivalent to stress AB times the area of the cross-sectional AB. Okay, so PAB is equivalent to 0.6527. No. So it is 0.5077 W is equivalent to the stress. What is the stress? We have 110 Newton per mm squared times the cross-sectional of 800 mm squared. Cancel, cancel. Therefore, W is equivalent 173.331 kilonewtons. Okay? Ang sabi doon, what is the lowest value that we will, the highest value that we're going to adopt? So, the highest value that we're going to adopt is 61.713 kilonewtons. Kasi pag si member AC, pinabuhat natin ng mag-i-exceed sa 61.713, it will fail. Okay? Compared kay AB na pag pinabuhat natin siya ng 61, it can resist the 61.713 kilonewton. While si AC, pag nag-exceed ng 61.713, it will fail. Therefore, this is the highest value.